In the second section of chapter 6, we will talk about the most important role of the routing layer, which is routing. So this section is divided into two parts depending on where the routing happens. So we'll talk about how a host routes. The other part talks about how the router actually routes. So the first part, for a host to route, there are three types of locations that the host can route to, whether it routes to itself, which means that it routes to a special address, which is 127.0.0.1, which is what we call loopback address, or it routes to another local host on the local area network, on the same local area network like PC1. Or the third type of routing, which is to route to a remote host, which means that it has to forward the packet through router R1 to the remote host. If a host wants to route a packet to a remote network, it routes the packet through what we call the default gateway. The default gateway is a special interface on the router that's connected to this host, and it forwards the packets to the remote network through activating the routing table on the router. So PC1 has three types, as we said. There are the direct connection through loopback, and there are local network route, which is which activates any destination on the same local area network, or the local default route, which is the router through. So how does a host figure out whether or not to forward the packet through the default gateway? So in that case, the routing table on this router is divided into three major parts. There is the special address inside the loopback to this host, which is what we call 127.0.0.1, which is refers to the direct connection. There is the default network route, which activates automatically the route to any host on the local area network. And there is the default gateway route, which activates the route through the default gateway to go to the remote network. So this is how the routing table inside the host looks like. To get this routing table, we simply run the netstat command. So if we can just go through a window and netstat dash, we get all the routing tables on all the interfaces that are connected to PC1. So for example, this PC has Wi-Fi, it has Bluetooth, it has Ethernet, and in Ethernet you have the IP version 4 routing table, you have the IP version 6 routing table. So we'll talk about the IP version 4 routing table now. So this is how the routing table looks like. You have multiple columns here. The first column is the network destination, which refers to the destination address. So if PC1 wants to send to a specific destination address, it has to look up this destination address in this column. The net mask, which refers to separating the network address from the host address. So this network destination is actually the network address, and to get the network address from any host address, we need to separate the network address using this net mask, as we will see in a minute. The gateway column is divided into two parts. Either we have to use the default gateway to route, which means that we want to activate the route to any host that exists on the remote networks, or it's on-link, which means that this destination address exists on the either inside the PC, inside PC1 activating the loopback, or it exists on the local network, which means that it's directly connected to PC1. The interface here refers to, again, two types. If it's 192.168.0.10.10, this means this particular interface which indicates that PC1 will send physically the packet across this interface to go out. Where if it goes out, it either goes to the local area network or it goes through the default gateway to the remote host. If PC1 wants to keep the packet inside PC1 and not exit it outside, in that case, it uses the interface 127.0.0.1, which means that PC1 will loop back this packet inside itself. The metric here indicates the cost that PC1 pays to send the packet to one of these destinations, and this metric increases as the route to this particular destination increases. But we will talk about the metric later on. So for now, forget about this metric column. So to understand the routing table inside the host better, we divided this routing table into 5 different sections. As we can see in the yellow section here, this refers to the default route that the PC1 uses to send any packets to any destination that exists on the remote network, which means that this is the default route in case the destination address does not match any of the rows of any of the remaining rows in all the other sections. The green section here refers to the loopback. So any address that ranges from 127.0.0.0 all the way to 127.255.255.255, this destination, this packet will be sent over the loopback, which means that it will not exit PC1 and it will stay inside PC1 as a loopback packet. If the destination is on a network which starts with 192.168.10.anything, and anything here is referred to by 255.255.255.0, which means that any destination address that starts with 192.168.10.anything, it will activate this row here, which means that it will exit PC1 to interface 192.168.10.10. It will exit here and it will go through the local area network. Section 4 here activates Class D destinations which use multicast. So multicast can be accessed either through loopback or through the exit interface of that host. And there is the broadcast again, which can be accessed through the 2 possible interfaces, whether loopback or the exit interface. So to understand this better, let's talk about a simple example. So if we assume that PC1 wants to send a packet to address 192.168.10.20. So what happens is that the host will try to match this address to one of these entries. And as we can see, 192.168.10.20, if we try this entry here, we will end up with this. So to understand this, let's just run this example quickly. So if we can switch here, so 192.168.10.20, if we can end this with the subnet mask 255.255.255.0. This operation is simple AND, so to AND all the ones together. So this means that up to this point, the IP address will be the same. And anything beyond this point, it will be 0. So the end result will be 192.168.10.0. If we notice this address, if we go back, this address actually matches the entry here. So it matches 192.168.10.0, which means that this entry will be activated. And the result will be that it's on link, which means that it's connected on the local area network or connected on loopback, and it will use this interface, which means that PC1 will exit the packet across this interface, which means that it will go to the local area network. And in that case, it will not go through the default gateway. Another simple example, if we assume that PC1 wants to send to a network address of 10.10.10.10. Okay, so in that case, if we look at these entries here, and we try to match this with any of these entries, we will find that it will not match any of these entries. In which case, it only matches this entry, which is 0.0.0.0, and it matches this destination address, which means that only this row will be activated, which means that it will go through the default gateway on interface 192.168.10.1, which is this one, and it will exit from this interface to the default gateway, and then it activates the routing on router 1 side, which is what we will talk about in a minute. So router 1 needs to be activated and forward this packet further. So for IP version 6, as we can see here, the routing table is much simpler, as we have discussed before. So the routing table has this if column, which indicates that the interface type that uses this entry. So, for example, 16 here refers to the Ethernet interface, and 1 here indicates the loopback interface, and so on. The metric here again refers to the cost that this PC will pay, and we'll talk about it later. And this network destination and how it's divided, which again we will talk about later, because each of these addresses will mean something, whether it's loopback or broadcast or unicast to a particular IP version 6 address, and so on. And as we said before, the gateway is on link in that case.